Nice. So the last part of this lesson, we'll look at density. Now, as this is a topic that you've covered extensively in maths and physics at GCSE, the way I've done this is I've written one of the more challenging questions that you could be expected to answer at A level. What I'd like you to do at this stage is I'd like you to pause the video, have a go at it, and see if you can get to the correct answer. If you're completely stuck at any stage, just unpause the video and then I'll work through the answer and bring in what you need to know about density in addition to what you've done at GCSE. It may also be worth you looking over some of your GCSE notes on density if you're struggling to remember anything about it. Right, so hopefully you've all had a go and seen where you get up to. I don't mind whether some of you are completely stuck or got to what they think is an answer. The important thing is that you understand each stage of the solution that I do now. I've deliberately written a question here which tries to bring in lots of different things because it's unlikely at A level you're going to be asked just a straightforward calculate the density of this question given the mass and the volume. So the first thing is, well, what is our definition of density? This is important, and if we can make sure you're following this through in your notes, that would be useful. So density is the mass per unit volume of a material. There's a formula that goes with this. It's given the Greek letter rho. Rho equals mass divided by volume. Nice straightforward formula. In this case is your density. Usually given in kilograms per meter cubed. This is your mass in kilograms, and this is your volume in meters cubed. This question is asking us to calculate the mass of 1 meter cubed worth of brass. So we're going to have to change this formula around. We get the mass equals the density times by the volume. And that's the formula we're going to use. What's the problem at this stage? We've got the density of copper and zinc, but we don't have the density of brass. How do we get there? The way I like to think about this is like the way you do weighted averages in maths. So the way I would do this is I would say, okay, the density of copper is 8.93 grams per centimetre cubed, and 70% of it's copper. So we say, okay, we've got 8.93, and we've got 70%, which is that. But we've also got the remaining 30% being zinc with a slightly lower density. So we're going to do our 7.140 times by 30, and because those are all percent per 100, to get our overall density, we've got to divide that, just as we would for weighted average in maths, to work out the density of our overall alloy. So we've got 8.93 multiplied by 70. We're going to add that to our 7.140 times by 30, and then we divide that by 100. That then gives us a density of 8.393, and our units here, because they've given you the density in grams per centimetre cubed, we haven't done anything to change that yet, so our units are going to be grams per centimetre cubed. always worth doing a bit of a sanity check with your answers. It's mostly copper and a little bit of zinc, so you'd expect the density to be slightly closer to copper, which is what our number is, and but slightly less because the density of zinc is less, which is what it's been alloyed with. So our answer does make sense. The last thing we've got to do before we substitute into the formula, so we've got our volume is 1 metre cubed. Our density at the moment is given in grams per centimetre cubed. So the question is, how do we get that into kilograms per metre cubed, which would be our SI unit for density? The difficulty here is converting your centimetres cubed into metres cubed, and I do see still when I mark exam papers loads of mistakes in converting between centimetres cubed and metres cubed. So I just want to show you a way of thinking about this that will be useful wherever you have to do this sort of thing. And the first thing to write out is something that really makes sense, and that is that 1 centimetre equals 0.01 metres. Because that's both sides are equal, we can square both sides, and they will give you another equation. So we end up squaring our 1 and our centimetre. We end up with 1 centimetre squared equals, well, we've got metres squared from squaring the metres, and we've just got to square our 0.01, and that gives us 1 times 10 to the minus 4. So there we've got our conversion between centimetres squared and metres squared. Well, how do we get then from centimetres cubed to metres cubed? We've got to times again, so this side by 1 centimetre, and we've got to do the same thing to both sides. Well, 1 centimetre is again 0.01 metres, so like that. So we end up with 1 centimetre cubed, and then we do that times by 0.01 again, and that is 1 times 10 to the minus 6 metre cubed. I'm sorry if you've already seen this before and if that's a bit repetitive, but please be careful when doing conversions between centimetres cubed and metres cubed. So we now know what our centimetres cubed to metres cubed is, and we know that 1 gram is equal to 1,000th of a kilogram. So we can then just take these two things and apply it to this density that we've got. So we've got 8.393 grams. So we've got to times that by 1,000, sorry. It's the same thing as saying divide by 1,000. And we've got to divide that by our conversion from centimetres cubed to metres cubed. So we end up with that. So we're dividing that by 1 times 10 to the minus 6. And when we do that, we get an answer of, just show, putting it into the calculator now, 6. And that gives you 8393 kilograms per meter cubed. I know that's a long method for going through all of that, but it is something that you will be tested on, in particular your paper 3s, where quite often you do practicals and get results which are in units of per centimetre cube. So it's really important that you're confident with doing these unit conversions. I'll try and set you some questions which rely on you doing that, but it's something that is really worth bearing in mind and practicing so you don't make silly mistakes in the exam. So we've got our density now, so we'll just remind ourselves this is our density of brass in the units we want it, and we said we're going to use this formula. We've got the density, we've got the volume, so we just end up with our answer, which is going to be our density, which is coming from 8393, multiplying that by 1, and that's telling us that 1 metre cubed of brass is going to be 8,393 kilograms, so about 8.4 tonnes. I'm going to leave it there for now. Over the half term, you've got some resources, you've got your textbook, you're also going to get more access to resources on Caboodle for revising this unit. I intend to put together an assessment for the first week back after half term. I'm planning on using Thursday's lesson for that, just to give you a little bit of extra time to revise. This is a short unit, as I've said, and in reality it's the practical aspect of it which is important as well, which I can't assess you on yet. And once you've done that, we'll be moving on to simple harmonic motion and circular motion, and the aim will be to have that finished by the summer.